Hi everyone. So this is the fifth session of writing a Lisp in Python. I'm going to, as usual, mount the remote directory before starting to work. Okay, I'm going to connect on the server. And last time I forgot to commit our changes, so I'm going to do it right now. So we implemented it seems like we forgot to save some changes. Oh no, it's not a problem. So I had a Vim temporary file that contained something I didn't need to save. So we changed, I think, these functions. I'm not sure. Yeah, we didn't change anything, almost. We changed this file. We added a function to create a list from Python parameters. And we added a new interpreter file that contains hooks for later implementing the interpreter. And we also added keywords and functions for which are used for the interpreter. And this was the first session. So this is now on the Git repository. So this time we are going to progress on the interpreter, and especially on the lookup function. The lookup function is going to how should I say it? The lookup function is just going to take a symbol and return the value inside the variable in the current scope. And for this function, I will need to implement environments or scopes. And an environment is going to be a Lisp value, so not a simple dictionary in Python. It's going to be Lisp hash table, and I'm going to use this to define a constructor in this file. And I'm just going to start with a Python dictionary. So the Lisp hash table value is just a wrapper over a Python dictionary. I'm just checking the spelling. Yes, it's correct. So I'm going to import this constructor. And an environment is going to be a dictionary that contains its own parent, refers to its own parent. So at any point in Lisp code, I can use the parent scope variable to refer to the parent of the current scope of the current variable environment. And I'm also going to define a reference to the environment itself, like this, with current scope. But first I'm going to create the Lisp hash table. I'm trying to find a good name for the new variable binding. So in Lisp, the current scope is going to be the Lisp value that is a wrapper over the environment, the dictionary. And the bindings inside the environment hash table are going to contain references to previous environments, to parent scopes, and to the current environment. And we are returning the Lisp value so that all of the interpreter manipulates environments or variable scopes as Lisp values. This means that Lisp code can create its own environments or manipulate the environment during interpreter functions. And this code, for example, this lookup function could be exposed to Lisp as a function. Same for the other functions, but I'm not going to do it now. So this can be removed. I'm going to create an environment with the constructor. Now this is an empty environment, and if I want to add a new binding, I have to use the value, the bindings inside the environment, which is the Lisp value. So for example, I could set this binding, but since we are using Lisp, this value has to be accessible and manipulated in order to manipulate it from Lisp. So we need to use, for example, a Lisp integer, which is defined here. So it's a simple wrapper. And I can remove this. So as soon as I create an environment, the environment has a reference to its parent, which can be known or another environment, and a reference to itself with current scope. I'm not going to use known, I'm going to use I'm going to use nil, which is defined in unique values. So that Lisp can try to access the parent scope and check if we are at the global scope, if the parent scope is nil, because none is a Python value and should not be exposed to the Lisp runtime. So now I'm going to define the lookup function. So assuming we have an environment created with this constructor and a Lisp symbol, which is just a wrapper over a string, I can just take the name of the variable from the symbol, the Python string, and the bindings from the environment. And if the variable name is in the bindings, then we have something like this with the name here, and we can return the value in the current scope. This code is going to return the value if if the value is found in the current scope, but since variable scopes can be recursively defined, we need to explore the parent scopes and give the priority to the closest scope. So if, for example, in Python I define x here, and then I define a function where I define another value for x, and then another function where I define yet another value for x. If I try to access x here, I need to check if there is an x in the current environment. If not, then in the parent environment, and if not, then in the global environment, and for this I'm just going to use recursion. And we can do it using the parent scope. I don't remember how I decided to implement the comparison in the unique values. I think I used equal like this, which is the same as is because we didn't implement an equality operator for Lisp values. So I'm going to use is here for clarity. If there is a parent scope, then we will delegate the lookup to the parent scope recursively. And if we get here, this means we didn't find a variable definition in the current scope or in the parent scopes, or rather that there is no parent scope anymore to explore. So we are going to return a value that indicates the lack of any definition. So we can't return nil, because nil would be returned if we try to look up the nil symbol. So we could, for example, return none, but if we do that, then the Lisp environment could not understand what none is. We could implement a special value like undefined, for example, which would never be used anywhere except during a lookup, or maybe like in JavaScript, for when a function does not return anything. In Lisp, the default return value is usually nil, so we wouldn't need to use undefined. But if we want to be type safe in definitions, we need to make sure that we can distinguish between a function that returns nil and a function that does not return anything. So if we were in Rust, we would use the option type, and the option type is either sum with a value or none, and this type can be nested, so I can put an option inside the option, and then I get this or this or this. So I can go if let's say I want to implement more complex algorithms based on the lookup function, and the lookup function can return nil, I may have a problem later if I can't make the difference between, if I need to be able to look up variables that are set to nil, and that's why I'm going to need another value. But I don't want to abuse the undefined keyword like in JavaScript, so for now I'm going to keep it for later. I'm not going to define this yet. I may do it later, but for now I'm going to assume that the Lisp code is never going to look up a function that does not return anything. And with none, I can use none as a special Python value for the interpreter to return an error if Lisp tries to look up a variable that does not exist. So I could have, for example, a function that tests if a symbol is defined and returns true or false depending on whether the variable is set or not, and this would let me return an error every time a lookup is done on a variable that does not exist. And because of this special value, in the interpreter I can also assume that if a variable cannot be looked up, then we have an undefined variable error, like in Python if I type a variable that does not exist. So this function is done. We can keep it that way. Then we have this three functions. I think I will need to implement some tests, some validation tests for lookup and for other functions. I'm not sure where I can do that. I think I will do it here. So I'm going to create a symbol with the a variable and try to look up the name, and I should get a 5. I'm also going to import the represent function, the native represent function. So that I can debug more easily my code. So I'm going to run the interpreter, and yeah, because represent returns the Lisp value. So I could create other values. I'm going to move the integer import here. And I'm going to define another binding. Yeah, no problem. And if I try to look up a function, symbol that does not exist, that is not defined in the table, I get none. Oh, okay. That's a problem. So I think what happened is that, yeah, this is the problem. This is better. So what was happening is that if there is no parent scope, then lookup is going to make a recursion with, and there is this problem also. Yeah. So this should have made an error in any way, because nil is not a proper environment. So this is because I forgot to replace the environment by its parent. And now I get the correct behavior. So I think this function is correct. I'm going to move this lines here. And I'm going to comment it because the tests are valid. So now we have 3 functions left to implement, and the lookup function is probably the simplest of all, because it's just checking if a name is in a dictionary. And these functions are a bit more complicated. So what we want for the compute function is to, depending on the I'm going to split it into a different function. So the compute function is going to take a function and apply it to its arguments, maybe evaluated and maybe not, depending on if we are processing a function call or a macro call or an axiom, a special function call. But the way that functions are computed depends on whether it's a native or Lisp defined function. So native functions are defined in Python, so it's just calling a function. But Lisp functions are defined with a body and an argument list and a closure environment. I'm going to take this line just to know what I am trying to process. So in the compute function, I'm going to to unpack the function object. So the function object is a console with the execution mode and the function itself. So this is execution mode, and this is the function object. I'm just checking that I did define these functions. Great. Now, if the execution mode is before eval, depending on whether we are processing a function, a macro, or a special function, we are going to process the parameters differently. So first, we are going to import these three keywords and the keyword module. If exec mode, if the keyword equality, so we are going to use the keyword equality to compare the execution mode and the different types of functions. So if we are in the case of if we are processing a function, the execution mode is going to be after eval, because the function is processed after evaluating the parameters. I think I should have make these names a bit easier to understand. So if we are in a function, then we need to evaluate parameters. And this is the tricky part. We need all these functions, expand, evaluate, and compute, are almost always recursively dependent. Mutually recursive. They are mutually recursive. So compute is going to evaluate is going to compute, and evaluate is also going to expand, and expand requires computing and evaluating. Expanding macro calls requires computing the macro itself. So all of these functions are going to be mutually recursive. So I'm going to switch to the evaluate function, and I'm going to implement the simplest case of no recursion with just simple data types and symbol lookup. And because we implemented in the value type a type attribute, we can test if the expression type is, for example, a symbol type, as long as we imported the types. So if we are processing a symbol, we can just return the lookup of the symbol in the environment. Then I need to process non-empty lists, so not nil but console. I think that's how the type is named. Yeah, cell type. This part is what I'm not going to implement first. So I'm going to raise an error, a to-do error. And for every other type, whether it's a keyword, a string, an integer, a unique value, or even a function, I'm just going to return the value itself. So we have defined evaluate for everything except function evaluation, function call evaluation, which is going to also apply to macro calls and special function calls like if, and, else, if, else, and other actions in Lisp. So now that we have defined the beginning of evaluate, we can test if the function works, and then we can use it here, even if it's not completely defined, because we can still use it on, as long as it's not a very complex complex expression with fun calls. And then once we have defined compute, we can implement evaluate with compute with mutually recursive code. So now I'm going to test the evaluate function. So I'm going to take these lines and reuse them. I'm going to evaluate an integer. I'm going to evaluate a symbol, so I need an environment. Okay, so I will take the same environment as I did for the lookup tests. I create an empty environment, I define A and X, then I try to evaluate the symbol A, which should return the lookup of A, which should return 5, which we know that lookup returns 5, the value, the integer value. And evaluating a Lisp value always returns a Lisp value, so we are going to return so evaluate is going to return a value that we need to represent for pretty printing, and then we print the Python string that is the represented Lisp value. I'm going to use a loop to be more to make the code easier to read. First we evaluate the value, the expression, then we represent the results. Into a string, and then we print the Lisp string. Okay, so what did I do? So it's the import that doesn't work. I can't import native function. Okay, I think that's just me missing this. And in the value definition, I don't know why there was an error, but now it works. Keyword arguments. Oh yeah, so I can't use keyword arguments and then stop using keyword arguments. It's just a Python thing. So it seems that like the code is working. At first I tried to evaluate a symbol which returned the value contained in the symbol, and then I tried to evaluate an integer, and I got the same thing as if I evaluated a variable that is equal to the value. So I know that the code is correct because I used represent, because if I tried to evaluate a string, for example, I would have received a string with quotes inside and not this literal. So for example, if I try to create a string, I don't get the characters, I get the literal string with quotes, because I implemented the represent function that way. So the evaluate function works for simple case, for simple values. I'm going to write it. So in typical Lisp, usually the evaluate function needs to check if we are evaluating special forms like quotes, for example, in which case we return the argument without evaluating the parameter of quotes. If we try to evaluate this value, for example, it's an empty list, so we would translate it to nil instead of calling it. And if we get we need to evaluate x before checking if it's true, then maybe y or z, depending on depending on the truth value of x. And there are many built-ins like AND that have special evaluation rules, like for example in AND, if x is false, y is never going to be evaluated, or has the same special rules where if x is true, then y is never going to be evaluated. And I'm not going to need any of that, because I decided that axioms like if and quote are just special functions with no evaluation flag, kind of like macros that are called before evaluating the parameter, but instead of moving the evaluation phase, I'm disabling it entirely, so I can call eval manually in my built-ins. So if, for example, I want to implement quotes, I just have to do this. And because I didn't, so I need to implement in the built-ins, I need to set the correct flag in the native function wrapper over quote. but that's it. I don't need to do anything else. I just need to put the quote special function in the built-ins, in the environment, the global environment, for quotes to be implemented in Lisp. I can do the same for quasi-quote if define lambda and anything I want, in fact. For example, and, or, all of these functions that have special evaluation rules, like quasi-quote with unquote, or if with the conditional evaluation. All of them can be implemented as built-ins instead of in the interpreter. This means the evaluate function is much simpler, right? And the interpreter will in its entire final version will still be pretty small compared to any other interpreter, even though this is Python and not a scheme. So if so I know that there are many examples of making a very small Lisp implementation in Lisp. I know that the record is I know that the minimum is something like 7 lines. Yeah. So if you want to make a Lisp interpreter in Lisp, you just need this. So you reuse the read function, but that's not what we are doing. We are implementing everything from scratch in Python. So we have the parser, and now hopefully we're going to finish the interpreter, and not today, but eventually we should be able to finish. And now that we have the evaluate function, we can just replace it in the compute function. We can just use evaluate in compute. So we are going to evaluate the arguments. This is this args parameter is a Lisp list, a console value or nil. So I'm going to process with a function mapping this Lisp, and I'm going to implement the map function. Okay, so I'm not sure how to implement the function. I'm going to keep the list immutable, so I'm going to first reverse the list and then process it in reverse. And I think that's it. So what we do here is that we reverse the list, and then we create a new list, a new empty list, and we take the elements from the reversed list, so from the last one, and push them with cons after processing them on the new list, and then we return the list. So I have this map list function that I can import from, that is imported in cell. And I'm going to return the evaluation of each argument, the result of the evaluation of each argument with the evaluate function. So this lambda will take each argument and return the result of evaluation in the current environment. So this is the entire code for evaluating parameters when calling functions. So if we are calling a macro, this code will not get evaluated, and if we are calling a function, then the parameters will be evaluated. Then we need to compute the actual body of the function, or call the Python function if it's a native function, and then we need to get a result, and if we are executing a macro, so if the execution mode is before eval, meaning that the parameters are the function body is computed before evaluating the result, then the result is going to be evaluated in the current environment. No, it's not going to be evaluated in the it's going to be evaluated in the current environment, but during the function compute code, I need to make sure to use the function environment, the closure environment, and create a new environment for the arguments. So these functions are defined to manipulate Lisp values directly, but I think I'm going to define to use a decorator to transform these functions into functions with the same interface. So for example, if I try to implement an addition function, the addition function requires several parameters and maybe variable numbers if I want to do it this way. And to implement this, I will need to be able to use the same wrapper over all of these functions with different tape signatures, with different argument counts. I will need a decorator or transformer or something that, or a wrapper anyway, that will receive an environment instead of the raw parameters. But I'm going to do this in here. and this is this part is just evaluating the results in the once the function is over, so there is no problem. It's not related to the function environment. Okay. I don't know if I should finish this function before, because we are not going to be able to test this function here. We are going to have to wait for the next session. And in order to test it, we are going to use evaluate here. So we are going to, because evaluate is not completely defined, we are going to use simple values like integers and strings to evaluate simple function calls or macro calls or whatever. I just remembered about it, but I had this pseudocode written last time. So the goal of the compute function is to calculate the output of this type of expression, where f is a list of arglist body and function and the function environment. So I'm going to use this here. But this depends on whether the function is a Lisp function or a Python function. So I need to first check if the type is a native function. I think this was the correct name, Lisp function type and native function type, yeah. And if the function is neither of these types, then we have a problem. Because this means that we receive the function, which is a function with an execution mode, and the inside is neither a Lisp function nor a Python function. Okay, so if we have a native function, then we don't have a closure environment. The function environment is only used in Lisp, in the functions defined in Lisp, because built-ins don't have a Lisp local and closure environment. And in the interpreter, we are not going to use the closure, so we are going to I don't know. We're going to use the global Lisp environment, I guess. Or yeah, I shouldn't use this environment, because this is the environment in which the function is called, not the environment that should be used by the function. So I'm going to have to use a global environment, for example, or maybe no environment at all. So I'm going to create an environment from scratch. No. I need a global environment. I need access to the global environment because if I define, for example, if I want to call a Lisp function from here, or if I want to call represent, for example, I should be able to use the Lisp rep function, and to do that I need access to the global built-in environment. So I think I'm going to move this to the built-ins. Yes, I'm going to define the environment constructor here, and I'm going to create the global environment here. And from the interpreter, I can just import the global environment. So I will need to populate the environment with this built-ins. I'm going to, I can't just do something like this because toString is a Python function, it's not a Lisp value, so this would be an incorrect value in the Lisp runtime. So I will need maybe a wrapper to define a function. And by default, the execution mode is going to be a function. I'm going to define function because that's the most common case. So I'm going to set the execution mode to after eval. And I'm going to build the wrapper with the native function.native function, which takes the execution mode and the function. Okay, so I think I can, now I should be able to do this. Okay, and if there is no bug, this will put the toString function inside the environment. And if I do this at the beginning of the file, then I can use a decorator instead. So for example, so the syntax would be something like define add or plus, and that's it. That's what I would expect to define the quote, inspect, and other functions, other built-ins. So I need to define a decorator, or I can make this into a decorator by returning the function after doing this process. So this is a decorator. This means that currently this is the function. These functions are going to be wrapped as Lisp values, and I'm not going to have I'm not going to have a parameter list like I would have here. So the arguments are just going to be how should I say it? If we have a native function, then the arguments are just going to be sent this way. So yeah, I think that's it. This is the function environment. The function execution environment is only going to be useful for literal Lisp function definitions with named arguments and enclosures and other special characteristics. And in the built-ins, I'm going to keep functions defined like this. I think I could name it built-in, for example, instead of define, because I want to define a define function. Because in scheme, in guide, for example, the define function is what is used for definitions, functions and variable definitions. But I could still call the global definition utility this way. So I'm going to try to define everything. I forgot something. So I will keep it that way. I'm going to define a built-in decorator that only takes a name and returns a decorator that takes a function. Okay. So this should be a correct decorator that can be used this way. now I have this function to define global definitions, global Lisp definitions, and I have these decorators that I can use to define what I want as a part of the function definition. Yeah, I have many new bugs because I changed too many things. So if I try to value is not defined in native function. Okay, I don't know how I made it this far without finding this bug, but apparently I never had a working function module. I don't know how I got this far without saying it. Okay, so at least even if the code doesn't work, the file does not have a syntax error. And so I can keep defining things. And for this function, which is not a function, it's an axiom, I'm going to define the execution mode to be no eval. Okay, so I would like to test this, but I already spent too much time. So I'm going to commit everything now, and the next time we are going to test the built-ins with the lookup function. We are going to look up the symbols we just defined to make sure everything is okay, and we are going to test the interpreter for the compute function. And we are going to finish writing it. So I'm going to commit everything. And push the changes. And we are done. So I'm going to unmount my environment and everything is clean. Goodbye.